In this demo, we'll be showing disaster recovery between two Kubernetes clusters, one production cluster using FlashArray and another rancher cluster using local storage. In between, pure FlashBlade will be used with PXDR. The clusters have already been paired together. You can see here that the storage status of this cluster pair and scheduler status is already ready. This means that cluster 1 and cluster 2 are already paired together, and the destination cluster is our DR site. We'll want to take a look at how Portworx is configured to use FlashBlade. Portworx uses a credential to make sure that it can use FlashBlade as the intermediate object store for snapshots in asynchronous DR. In this location, we can see that the object store for DR is created, and we are in fact using a number of different objects already in our demo. The endpoint that Portworx uses is the FlashBlade data VIP, as you can see here in our configuration. This makes sure that Portworx in the disaster recovery mode uses FlashBlade. You can see from the cluster pair information that the IP and port of Portworx and the mode is set to disaster recovery and the destination token. So between this and the credentials, you will be using FlashBlade for PXDR. So now what we're going to be doing is showing a demo of a disaster recovery scenario to our destination cluster. Our destination cluster is our disaster recovery site, or DR site for short. The first thing we'll want to identify is what application we'll be working with to fail over to our DR site. In this case, we'll be working with MongoDB, and we've set up our cluster pair to target a FlashBlade Solutions namespace. You can see MongoDB running within this namespace here. Now let's pop into that database and look at our test database that we'll be working with. Here you can see that there's roughly 29,000 records in our database. As we go through the DR scenario, we'll add data from our source cluster and make sure it's propagating to our DR site before we fail over. The first thing a migration or a DR use case needs is a schedule policy. This defines your recovery time objectives and recovery point objectives. In this case, we set the interval very low to 5 minutes. This means our RPO will be roughly 5 minutes, as data will be snapshotted and migrated to our DR site every 5 minutes. Here, we want to make sure that schedule policy is used in something called a migration schedule. This defines how the migration and DR use case works. It references the schedule policy, and it's live, which means not suspended. The cluster pair, as you saw before, is our destination cluster. We want to include all the resources of the applications within the namespace we're targeting, which is our FlashBlade solution namespace. And we want to make sure we're staging our DR site, kind of keeping it warm. So our start applications is set to false. You can see that our daily and interval-based schedule policy is active and currently successful. So what this means is that we have our two clusters paired together, and we have a migration schedule using a policy active right now. So we should be able to see migrations that are currently occurring. You can see every 5 minutes, and the last 2 have occurred recently. If you want to get more details about what's happening on these interval-based migrations for DR, you can use the storkctl CLI tool to list the migrations. Here you'll see the last 2 or 3 migrations that occurred based on your schedule policy, and you'll see the status and the stage, as well as how many volumes and resources that are part of the migration. In this case, our current status was it was migrating applications, it's in progress, it migrated 1 volume, and finally completed with 6 resources. These resources are things like stateful sets, services, secrets, config maps, and our volumes are our PVCs. So now we want to see how the disaster recovery technique works when you want to fail over an application. So in this case, we know that our migration is active and staging applications in our DR site, which is our Rancher cluster. Here you can see the MongoDB is staged and created a few seconds ago. Our latest migration staged it, but notice it's not running, right? Our start applications configuration was set to false. This means we're just keeping this object and data warm so that we can fail over. Now, when you want to fail over, what would normally happen is you'd actually have an outage. But in this case, we're going to suspend our migration to simulate an outage. That stops migrating data and objects to our destination cluster. And on our DR site, we can see that there are currently no pods in our DR site. But in order to activate our migration that's part of our DR scenario, we can use storkctl to activate migrations in the namespace. This will spin up the pods or replicas that are part of that application staged. And so now our application is turned on. So our application, resources, and data are now on in our DR site with the latest migration. We can exec into this container and view the records in that database to make sure it has the latest data. We know we had roughly 29,000 records, so we can go into our test database and count the records in our zips collection. 29,354. This was the same number of records we saw in our primary site. You might be wondering, how does it continue to be updated if you add data to your primary site? To simulate this kind of activity, we're going to deactivate our DR site. This makes sure that things go back to a staged or warm state. You can see MongoDB is now 0 replicas running and ready to be activated again. All we need to do on our primary site is unsuspend our migration that we suspended before, and you can start using the primary site for your data once more. So we use the resume command on our migration schedule, and therefore our migration starts happening. So now what we can do is go into our Mongo database on our primary site, navigate to the database test, and insert a number of records. We're going to insert a bunch of records here and simulate the primary site or production site being used. In the background, remember our DR scenario is running the migration, so snapshots and resources are being updated in our DR site. You can see there's 29,360 records now. So let's wait for the next migration to occur. Remember, migrations happen every 5 minutes with our schedule policy. This is asynchronous DR, so RPO values are low, but not 0. You can wait till the next migration occurs. And here we can see our next migration started. The volumes will be migrated first, which means our new data should be migrated to the DR site. Once that volume is migrated to the DR site, the resources occur. Note that in this scenario, volumes aren't full migrations. Only the data that's changed is being moved to our DR site. Once the volumes are migrated, the migration moves on to the applications and migrates all of those latest resources. This helps when you upgrade or update things like volumes, images, environment variables, and the like. So our migration completed, and now our DR site should have the latest information and data about the application. So let's suspend our primary site and activate our DR site once more. So our DR site now is activated, and we can see our pod is now running and online. You can see it was created a few seconds ago. Let's do the same thing and drop into the Mongo database shell and log into the database. We can run the same commands as we did before by using the test database and listing the zips information. You can see now it's updated and has the 29,360 records as we did on our primary site, showing that the migration is occurring until a outage occurs and the DR site is activated. Until next time, take care.